Flying has always fascinated us, whether it's watching airplanes soaring through the skies or seeing a bird glide effortlessly. Have you ever wondered how these things can stay up in the air? Let's take a deep dive into the science and engineering that make flying possible, exploring the mechanisms behind airplanes, hot air balloons, helicopters, and even some living creatures. How do airplanes fly? Airplanes are a marvel of modern engineering, enabling humans to travel across vast distances in just a few hours. But how does something so massive manage to stay aloft? The key lies in the interplay of forces and the unique shape of the airplane's wings. When a plane is ready to take off, the pilot starts the engines, which produce a force called thrust. This force propels the plane forward along the runway at increasing speeds. As the airplane moves faster, its wings interact with the air in a special way. Though we can't see air, it's all around us, and it exerts pressure on objects. This pressure is crucial for generating lift, the force that allows planes to rise into the sky. The wings of an airplane are designed with a specific shape called an airfoil. The top of the wing is curved, while the bottom is relatively flat. As the airplane speeds forward, air moves over and under the wings. The air traveling over the curved top surface must move faster than the air beneath the flat underside. This difference in speed creates a pressure imbalance. There's less pressure above the wing and more pressure below. The higher pressure beneath the wings generates lift, pushing the plane upward and into the air. Pilots have control over the amount of lift and thrust the plane produces, which allows them to climb, descend, and maneuver through the sky. Special panels on the wings and tail of the airplane, called control surfaces, help adjust how the air flows around the aircraft. This ensures a smooth and safe flight, whether the plane is taking off, cruising at high altitude, or preparing to land. The science behind hot air balloons. On a clear day, you might spot a colorful hot air balloon floating gracefully in the sky. Unlike airplanes, hot air balloons don't rely on wings or engines to fly. Instead, they use the properties of air and heat to achieve lift. A hot air balloon consists of a large fabric envelope, or balloon, and a basket beneath it for passengers. The air inside the balloon is heated using burners, which produce flames. When air is heated, its molecules move faster and spread out, making it less dense than the cooler air outside the balloon. This difference in density causes the hot air to rise, lifting the balloon off the ground. The principle that governs this process is similar to why warm air in a house tends to rise to the upper floors while the cooler air remains downstairs. The hot air inside the balloon is less dense than the surrounding cooler air, allowing the balloon to float upward. To descend, the pilot can release some of the hot air through a vent at the top of the balloon, replacing it with cooler air and increasing the balloon's density. While hot air balloons don't offer the speed or maneuverability of airplanes, they provide a unique and serene way to experience the skies. The simplicity of their design showcases how even basic scientific principles can be harnessed for human flight. Helicopters. The art of hovering. Helicopters are another type of flying machine, but they operate quite differently from airplanes. Unlike planes, which rely on wings for lift, helicopters use rotating blades that act like giant fans to generate the force needed to fly. A helicopter's blades are angled slightly upward. As they spin, they push air downward, creating an equal and opposite force that lifts the helicopter into the air. This principle, based on Newton's third law of motion, allows helicopters to hover in place, fly backward, and perform other maneuvers that airplanes cannot. Flying on Mars presents unique challenges because the planet has a much thinner atmosphere than Earth. To address this, NASA developed the Ingenuity helicopter, which was the first aircraft to fly on another planet. Ingenuity is lightweight and has long, fast-spinning blades designed to maximize lift in Mars' sparse atmosphere. The success of Ingenuity has opened new possibilities for exploring other planets using flying machines. The journey of rockets. While airplanes, helicopters, and hot air balloons are designed to navigate Earth's atmosphere, rockets are built to venture beyond it. Rockets are some of the most powerful machines ever created, capable of escaping Earth's gravitational pull and reaching space. The secret to a rocket's power lies in its engines, which mix and ignite hydrogen and oxygen to produce a massive amount of thrust. This thrust propels the rocket upward, pushing against the Earth's surface and overcoming the force of gravity. As the rocket climbs higher, it sheds its outer layers, or stages, to reduce weight and conserve fuel. Gravity plays a crucial role in keeping us grounded, but rockets use its effects to their advantage. Once a rocket reaches a certain altitude, Earth's gravitational pull weakens, allowing smaller engines to carry the spacecraft the rest of the way to its destination. This innovative engineering has enabled humanity to explore the Moon, Mars, and beyond. Living creatures that take to the skies. While human-made machines dominate the skies, they're not the only ones capable of flight. Birds, insects, and even some mammals have evolved to use wings for movement. Each of these creatures has a unique way of flying, adapted to its environment and needs. Take the albatross, for example, a large seabird known for its long, narrow wings. These wings allow the albatross to glide effortlessly over the ocean for long distances in search of food. In fact, some albatross species can travel around the world in just a few weeks. Their flight is efficient, resembling the way airplanes travel long distances. In contrast, bees have short, stubby wings that enable them to hover and make quick movements. This helps them navigate from flower to flower as they collect nectar and pollen. Their style of flight is more like a bus making frequent stops compared to the long-haul journey of an albatross. Penguins, although they have wings, don't use them for flight in the air. Instead, their wings function like flippers, propelling them through the water to catch fish. The streamlined shape of a penguin's wings is perfectly suited for swimming, highlighting how evolution tailors wings to specific needs. The joy and wonder of flight. Flight, whether by machine or living creature, is a testament to the incredible forces of nature and human ingenuity. From the thrust of airplane engines to the spinning blades of helicopters and the heated air inside balloons, each flying mechanism relies on scientific principles that are both simple and profound. It's amazing to think that these principles, grounded in physics and engineering, have unlocked humanity's ability to explore not only our planet but the vastness of space. Understanding how flight works can make us appreciate the world around us even more, reminding us of the seamless connection between science and wonder. The next time you see a plane taking off, a hot air balloon floating in the sky, or a bird soaring overhead, take a moment to marvel at the forces and designs that make it all possible. These incredible achievements serve as a reminder that human creativity and the natural world can combine to produce some of the most breathtaking experiences imaginable. As humans, we've always been drawn to the skies, and our journey into the air continues to evolve. Who knows what new flying machines or techniques we'll discover in the years to come? For now, let's embrace and celebrate the magic of flight as both a scientific triumph and a source of endless inspiration. Thanks for watching. If you've ever dreamed of flying, whether like a bird, a bee, or even a hot air balloon, just remember it's all about the science and maybe a little magic. Don't forget to like, subscribe, and share, because who knows? Your next flight might be on a rocket to Mars or in a paper helicopter you made at home.